Welcome to the Cypress College Math Review on simplifying complex fractions. The technique we're going to use is to simplify each complex fraction using the LCD, the least common denominator, to clear the extra denominators found in the fraction. Let's take a look at example 1. We have in the numerator 2/3 plus 5/6, and in the denominator we have 7/9. Now what we want to do is find the least common denominator of all these extra denominators. So we have 3, which is prime. We have 6, which is factored to 2 times 3. And we have 9, which is factored to 3 times 3, which is 3 squared. Now, if you remember from your algebra class, to find the least common denominator, we want to take the highest exponent of each factor that appears. So there is a 2 that appears, so our least common denominator has to have a 2 in it. We see there's a 3 that appears and a 3 squared. So we have to take the highest exponent, which is 3 squared. So our least common denominator is going to be 2 times 9, which is 18. Now we're going to use this to clear out the extra denominators. So our goal here is to clear out this 3, 6, and 9. Now the way we do that is to multiply this entire fraction by 1 in the form of 18 over 18. So it's really important to remember that what we're doing here is multiplying by 1. We're not multiplying by 18. We're multiplying by 1 in the form of 18 over 18. When we multiply two fractions, we know we have to take the numerator of the first fraction times the numerator of the second fraction. So let's draw our fraction bar here, and we see we're going to have to take 2/3 plus 5/6 and multiply that times 18. Now the 18 will distribute to each of those two terms, so we will get 2/3 times 18 plus 5/6 times 18. Next, we have to do the denominator times the denominator. So we can see we're going to get 7/9 times 18. Now we can simplify in each of these multiplications now. 3 goes into 18 6 times, and we have that 2 times 6 is equal to 12. In the next one, we have 6 goes into 18 3 times, so we're going to get plus 15. And in the denominator, we have that 9 goes into 18 twice, so 7 times 2 is 14. When we add 12 and 15, we get 27, and the denominator remains 14, and there's our solution. In example 2, we have 4/7 plus 2/3 over 5/6 minus 1/7. So once again, we're going to want to find the LCD first. So we have denominators of 7, 3, 6, and then another 7. Now 7 and 3 are both prime. 6 we know is 2 times 3. So now when we find our LCD, we see we're going to need a 7. We're going to need a 3. And we're going to need a 2. So our LCD will be 7 times 3 times 2, or you can think of it as 7 times 6, which is 42. So we come back over to the original fraction, and we're going to multiply by 1 in the form of 42 over 42. Now we're going to use the same technique we used in example 1. We know that 42 is going to have to distribute, so we get 4/7 times 42 plus 2/3 times 42. In the denominator, we have to distribute the 42 over the 5/6 minus 1/7, and we get 5/6 times 42 minus 1/7 times 42. And now we're ready to do some reducing within each of these multiplications. We know that 7 goes into 42 6 times, and 4 times 6 is 24, plus we have 3 goes into 42 14 times, and 2 times 14 is 28. In the denominator, we have 6 goes into 42 7 times. 5 times 7 is 35, minus 7 goes into 42 6 times, and 1 times 6 is 6. Now we just have to do the addition and subtraction in the numerator and denominator. 24 plus 28 is equal to 52, and 35 minus 6 is equal to 29. And there's our solution, 52 over 29. In example 3, we introduce variables for the first time. We have x over 6 plus y over 9 in the numerator, and in the denominator we have x minus 2 over 12. So we proceed as before, where we first find the LCD, and the extra denominators we have are 6, 9, and 12, and we do the prime factorization for each one. 6 is equal to 2 times 3. 9 is 3 times 3, which is 3 squared. And 12 we know is 4 times 3, so we can write that as 2 squared times 3. Now the LCD will be made up of the highest exponents of each factor. So we have a 2 squared here that we'll use, and we have a 3 squared that we'll use. So our least common denominator is 4 times 9, which is 36. Now we come back over to the original problem, and we're going to multiply by 1 in the form of 36 over 36. Now, as before, we have to take numerator times numerator, so we'll be distributing that 36, and we get x over 6 times 36 plus y over 9 times 36. We have to multiply denominator times denominator, so now we have x minus 2 over 12, that has to multiply 36. We can cancel in each of these multiplications, and we see that 6 and 36 have a common factor of 6, so 6 goes into 36 6 times. X times 6 we write as 6x plus, in this next multiplication, the 9 and the 36 have a common factor of 9, so we'll cancel the 9 into the 36 4 times. Y times 4 we write as 4y. In the denominator, 12 and 36 have a common factor of 12, so we'll cancel the 12 into the 36 3 times, and we'll be taking the x minus 2 times the 3. So finally we get 6x plus 4y divided by 3x minus 6 when we expand that out. In example 4, we have x plus 7 over 2x plus 5 over 3y being divided by 2 over x squared minus 11x over y. So for the first time we have variables in the denominator, but we proceed in the same way. Our denominators are 2x, 3y, x squared, and y. So now when we find the LCD, we still have to find the largest exponent of any factor. So for the coefficients, we see we have a 2 and a 3. They're both to the first power, so the LCD will need a 2 times 3. We see we have an x variable here, but down here we have an x squared. So then we'll need to put x squared in the LCD. And then in 3y and in y, the y is to the first power, so that will be part of our LCD. So our LCD is going to be 6x squared y. We come back to the original fraction, then we're going to multiply by 1 in the form of 6x squared y over itself. Now we're ready to multiply numerator times numerator, which means we'll be distributing, and we'll get x plus 7 over 2x times 6x squared y plus 5 over 3y times 6x squared y. And in the denominator, we'll have 2 over x squared times 6x squared y minus 11x over y times 6x squared y. Now in each multiplication, we'll need to do some canceling first. So if we take a look at this first one, 2 goes into 6 3 times, and x goes into x squared x times. So we'll actually be doing x plus 7 times 3xy. In this second multiplication, 3 goes into 6 twice, and y cancels the y, so we will be taking the 5 times 2x squared. In the denominator, we have x squared canceling the x squared, so the 2 will multiply 6y minus, we have this y canceling this y, and we'll have to take 11x and multiply it times 6x squared. We're ready now to expand out to get the final answer. And in the numerator, we'll need to distribute this 3xy over the x and the 7. So we'll get 3x squared y plus 21xy plus, over here it's a straight multiplication, 10x squared. In the denominator, we will get 12y minus 66x cubed. And there's our result. In example 5, we see our denominators are x minus 2 and x plus 3, and down here it's just another x minus 2. So then our LCD will be the product of those two denominators, x minus 2 times x plus 3. So we'll come back over here to the original fraction, and we'll multiply by 1 in the form of the LCD over itself. So x minus 2 times x plus 3 over x minus 2 times x plus 3. Now we'll take numerator times numerator, which means we'll need to distribute. So we'll have x over x minus 2 multiplied by x minus 2 times x plus 3 plus 5 over x plus 3 multiplied by x minus 2 times x plus 3. In the denominator times denominator, we see we're going to get 8 over x minus 2 multiplied by x minus 2 times x plus 3. Now we're ready to look at each product on its own and cancel whenever possible. So in this first product, we see that we can cancel x minus 2 with x minus 2, and we will have x times x plus 3 left. In the second product, we're going to be able to cancel x plus 3 and x plus 3, and we will have left 5 times x minus 2. In the denominator, the x minus 2 will cancel with the x minus 2, and we will have left 8 times x plus 3. Now we can expand each of those out, and we will get x squared plus 3x plus 5x minus 10. In the denominator, we will get 8x plus 24 and we can combine like terms here, the 3x and the 5x, So our final result will be x squared plus 8x minus 10 over 8x plus 24. Now in example 6, we see our three denominators are x squared minus 9, x minus 3, and x plus 4. Now x squared minus 9 is the only one that can be factored, and it becomes x plus 3 times x minus 3. So our least common denominator is going to involve an x plus 3 an x minus 3. Now this x minus 3 is already taken care of, and then an x plus 4. Now that's what we'll use to multiply by 1 in the form of the LCD over itself. X plus 3, x minus 3, and x plus 4 over itself. Now we're ready to multiply numerator times numerator. And my suggestion when you write this first term is that we will take the denominator and write it in its factored form, anticipating that we're going to be canceling. So we have 8x minus 1 over x plus 3 times x minus 3. And that has to multiply x plus 3, x minus 3, x plus 4. Next, we'll take denominator times denominator, and we're going to have to distribute. So we'll get 4 over x minus 3 times the LCD, x plus 3, x minus 3, x plus 4, plus we have 3 over x plus 4 times the LCD, x plus 3, x minus 3, x plus 4. Now we begin to do some canceling, and in the numerator we see that x plus 3 will cancel with x plus 3, x minus 3 cancels with x minus 3, and we'll be multiplying 8x minus 1 times x plus 4. In the denominator, we have x minus 3 will cancel with x minus 3, and we'll have to multiply 4 times x plus 3 times x plus 4. Then we have plus. In this last product, the x plus 4 will cancel with the x plus 4, and we'll have left 3 times x plus 3 times x minus 3. All right, now continuing to simplify, we'll need to FOIL out the numerator. So first times first is going to give us 8x squared. Outer times outer will give us plus 32x. Inner times inner will give us minus x. And last times last will give us minus 4. In the denominator, we'll first want to FOIL this out before we take it times the 4. So we'll leave the 4 alone for now and go first times first is x squared. Outer times outer is plus 4x. Inner times inner is plus 3x. And last times last is plus 12. Also in the denominator, we'll want to leave the 3, just like we left the 4 a minute ago. And x plus 3 times x minus 3 is a special product, so we can write that as x squared minus 9 in one step. We combine like terms in the numerator, and we have 8x squared plus 31x minus 4. In the denominator, we have 4 times x squared plus 7x plus 12 plus 3 times x squared minus 9. Now in the denominator, we can go ahead and distribute in the 4 and distribute in the 3. So now we have our numerator, 8x squared plus 31x minus 4, and in the denominator, when we distribute, we're going to get 4x squared plus 28x plus 48 plus 3x squared minus 27. And now finally, when we combine like terms, numerator remains unchanged, 8x squared plus 31x minus 4. And in the denominator, we have 4x squared plus 3x squared is 7x squared. 28x, and there's no other x term, so plus 28x, and 48 minus 27 is plus 21. And there's our result. For some extra practice, you can try these 3 problems on your own and then check your answers with those given below. Good luck, and I hope this has helped you in your understanding of simplifying complex fractions.